Drones are causing absolute chaos to airports and have cost airlines tens of millions of pounds. Prisons are seeing drugs as well as weapons being smuggled inside via these drones, and militaries and governments across the globe are terrified about terrorist bomb attacks from drones. We need to solve this drone problem, so what I'm going to do is I'm going to combine the stability of a rocket and the control and the manoeuvrability of a drone to drive straight towards the enemy target drone that we're trying to take out and catch it with a net. So let's get designing. I started by using CAD and computational fluid dynamics to rapidly iterate and improve the design. Then I had to integrate the control electronics. This meant I had to pack a radio receiver, the computer vision circuit, flight computer, CPU, 2 intricate winch mechanisms, the propulsion system and a battery into a space no bigger than a shoe. Here is what the complete drone will look like. The onboard camera tracks a target, and just before impact the drone will partition, unleashing its central net, catching and neutralising the drone threat. I started manufacture by 3D printing the components. Then I had to do the boring bit and assemble and program the control electronics. Here is a test of the real-time target tracking system. Now I'm just preparing the system for its first propulsion test. And as you can see, this thing has a lot of power. Now I have confidence in the entire system. I'm going to get the entire thing assembled and actually take it for its first proper test and maybe even get it hovering. Oops, that wasn't meant to happen. Look, this thing needs a lot more stability and calibration. However, I believe that it is a viable concept. With a bit more time and development, this could prove to be an exciting start to making our skies a safer place.